Hello and welcome everyone. Welcome to the first session on algebra. My name is Rupen and we are going to start with a new series from today. So this is the topic of algebra and we are going to look at some of the questions today on expressions and identities. So let's start with the session. So here's the first one. Please try this one for a minute and we'll discuss. Let me know if you're able to do this. So in today's session, we are planning to keep some of the very relevant questions on algebra. Some of them are previous year questions also. So let's start with some of the different questions on algebraic expressions and identities. So these questions will be making use of all the different uh, relations that we know in algebra. For example, what is the expansion of a plus b whole cube, a minus b whole cube, uh, and different factorization rules. So I'm looking at the chat box. If you're getting the answer for this question, then let me know. All right, so let's start. How to do this question? So the logic in this question is that you see basically a recurring stream of numbers which are repeating themselves. So these kind of questions require us to identify where the repetition starts. All right. So when we look at this expression 1 plus 2 over 1 plus 2 over, so it's a repeating pattern, right? So how to solve for x? Likewise over here for y. Because to answer this question, we have to solve for both x and y. Only then we can find the value of x square plus y square. So if I carefully look, then what I have over here is exactly what I see at the beginning, right? So I can replace this expression as x itself effectively. Yes or no, right? So that is the point. So if I write this, then I can say x is 1 plus 2 over x itself, and that becomes a equation which can be easily solved for, right? And we can find the value of x. All right, so if I just multiply with x now, then I get x square equals x plus 2. So now this is a quadratic, and then this becomes x square minus x minus 2 is 0. Now does this have a factorization? Yes. Easily we can see that this is x minus 2 into x plus 1, right? So now x is either 2 or minus 1 from here, but if I look at x, it is obviously a positive number. Because it is 1 plus another number which is clearly a positive quantity, 2 over 1 plus 2 over. So obviously minus 1 is a uh, erroneous value, something that we have to reject over here, because we know that in quadratic sometimes we get a wrong answer. So x is obviously 2. Likewise, what we can write over here, again square root of 2 plus. So now what I see further from here, this is exactly what I had to start with. So I can again write that y equals square root of 2 plus, then what follows further is again y. So therefore y square equals 2 plus y. Now y square minus y minus 2 is 0. This is exactly the identical equation as we have over here. So this also has the same solutions, y is 2 or minus 1, and we'll accept only 2. So x and y, both of them are 2, right? And therefore, we can find x square plus y square is nothing but 2 square plus 2 square, which is 4 plus 4, 8, right? So the logic of this problem was the recurring pattern that we have. Perfect. All right. Let's go to the next one. Second one. All right. So I'll give you a minute again to try this. So you can let me know if you can figure out how to go about this. I'm looking at the chat box. Anything that you're able to think through. I'm not necessarily just looking for the answer from you, but also how do you think we should go about this, right? Let's discuss. Yes, Ryan. Nothing is hard. Everything is done for the first time, and then it becomes easy, right? So don't worry. We are going to do all the relevant questions in my session. I'm going to keep it very relevant as per the current exam pattern. Don't worry. All right, so let's start. Now, you can see that we have two equations in x and y, right? So algebra tells us that if we have as many equations as is the number of variables, we can solve the given variables, right? But solving these two equations will be a tough nut to crack, right? Algebraically, because this is a linear equation, whereas this is a third degree equation. So we are familiar with linear and quadratic equations, but we haven't solved algebraically, higher order equations. So the point is uh, that sometimes we need to identify the numbers themselves. Sometimes it is not algebra but numbers logic which helps us to solve the equations. Means, can we try to figure out what numbers actually can satisfy these equations? If they are uh, whole numbers or integers by chance, and if we can figure that out, then we can easily solve. So just think about this: the two numbers when added equal 3, and the sum of their cubes is 9. Now two numbers equal 3. Now I can think of 1 and 2 being equal to 3, right? So 1 plus 2 equals 3. Now, if 1 and 2 also satisfy this equation, then x and y are 1 and 2 itself. And indeed, that is happening because 1 cube is 1 and 2 cube is 8. So 1 plus 8 indeed equals 9. So this verifies that x and y are nothing but 1 and 2, whereby which one is which, we I don't know. Maybe x is 1, y is 2, or other way around, it could be x is 2 is y is 1. But any which way, 1 and 2 are the numbers. Now therefore, whatever be the order in which x and y are taking these numbers, I can always say x power 5 plus y power 5 is 1 power 5 plus 2 power 5, which is 1, and this is what, 32. So the answer is 33, right? So in this way, sometimes number identification is required in algebra, right? Obviously, algebraic method is complicated. So, ready for next one? Yes. Okay. Let's see. Third one. Oh, this is the same question, but a different one. The exact same question with the similar equations, but numbers are different now. Okay. So this will require algebra, I guess. Okay, I'll again give you a minute to try. You can take 2 minutes as well. All right. So in this one, obviously we cannot identify the numbers, right? Because x and y is 2, so 1 plus 1 equals 2, right? But 1 cube plus 1 cube is not 5, it is 2 itself. So it's not possible to find the numbers because they are not whole numbers. So algebra will be required. All right. So look at the objective. We have the power 5 over here, we have power 1 and 3 over here. Now such kind of questions are dealt with by basically, you know uh, trying to break the power into smaller powers which we can find. So what I'm trying to say is that this is power 5. 5 is 3 plus 2. So what I'm saying, if we can somehow figure out uh, the value of, let's say, something like x squared plus y square, all right, let's say, and x cube plus y cube also, let's say, we have already that with us. So if we can find this along with knowing this, then we can try to reach this, because 2 plus 3 is 5. That's the logic. So just break the power into smaller parts which we can find. So step one, that we, so some manipulation is required. Let's do that. Let's first of all cube this equation, right? Simply because I know that if I cube this equation of x plus y, I'll have this with me, right? So x plus y whole cube, we all know the expansion is x cube plus y cube plus 3xy times x plus y, right? So this equals 8 from the first equation by cubing it, whereby now I can replace for this x cube plus y cube as 5 from above, right? So therefore 5 goes over there, and therefore in the next step I can say that 3xy times x plus y. Oh, x plus y itself I know is 2 also. So I know this is 2. So 3xy into 2, and this equals 8, and this was 5. So 8 minus 5, this is 3. So this is 6xy equals 3, or you can say x into y is 3 by 6, or half, or 0.5. So this is one value that I got. Now, how does this help me? Well, let's see. I was saying that we basically need to reach to x square plus y square, isn't it? So now, again, the same equation, the first equation, which I had first done cubing on both the sides. Now I will do squaring on both the sides. Uh, I'm getting the response approximation can be used, right? So, that might be a way, right? I'll just explore that also after I do this, right? Can we think of numbers which satisfy, which are obviously not whole numbers? That might be a bit difficult this time, because we are not dealing with integer values, right? Nevertheless, let's see. So now I was saying, let's square both the sides now once again. So x square plus y square, this one, plus 2xy equals 4, right? And now, so I was saying this x into y, what was its use? Now it will be used over here. right? So this becomes 1, 2xy becomes 1 from here. So using that, I can say that x squared plus y squared is 4 minus 1, which is 3. So these two results, that x cube plus y cube and now x squared plus y squared, now I can use them together. So let's multiply them, because then the powers I'll be able to reach to that, right? So multiplying the two equations, x squared plus y squared into x cube plus y cube, which equals now 5 into 3, 15, right? Now the expansion of this will give me the required value, right? A required expression. So this gives me x power 5 from here and y power 5 from here. But apart from that, I'm also, this is power 5, and also I'm getting x square y cube and x cube y square, which can be written as, by taking x square y square common, x plus y, x square y cube plus x cube y square. Now I know this value as well as this value, so I can insert that. This equals 15. So I think we have the answer now. X power 5 plus y power 5 is therefore 15 minus, now xy was half, so x square y square will be half square, 1 by 4, into x plus y was 2. So this is 1 by 4 into 2 is half. So 15 minus half, 14 and a half. Right? So option C. So yes, so I think this is one of the ways, and uh, figuring out what numbers actually can satisfy this, I think, can be a bit challenging. So yes, algebra is definitely required in this question, right? But I'd love to see if you have some brilliant solutions. Let me know in the chat box. I'll be responding to all your comments. All right, let's see the next one. All right, so quite a similar one. Let's see how we can do this. I have shown you two questions on a similar line. Now this is the third one, so I'm expecting that you have some way out for this one. Let's see. All right, let's go for this now. So we have seen two questions. In the first one, we basically figured out what the numbers were. We did not do algebra. In the second one, finding what the numbers were difficult, and then we resorted to the algebraic manipulation and looking at the objective and working on that. Right now, so obviously, if numbers we can figure out is the easier approach, right? So let's see, can we figure out the numbers? Now, looking at the fact over here, x squared plus y squared is 5. Again, the smallest numbers, which is like 1 and 2. So they satisfy this, isn't it? 1 square plus 2 square equals 5, right? So now, however, our aspirations are let down by the fact that 1 cube plus 2 cube is not 7. 1 cube plus 2 cube is 9. So now how do we do this? We have to go for algebra. Yes? No, not. Actually, the point is, a little observation is required, a smart observation. You see, I'm getting this as 9, but this is 7. So think, this was 1 plus 8, 9. But if this could have been minus 1, then this would have matched with 7. And for that, this 1 should have been written as minus 1. And over here, if I replace 1 with minus 1, it does not matter, because minus 1 whole square is also 1, and 1, and this equation is still valid. So therefore the point is, you need to think with negative numbers as well. The fact is that over here, minus 1 comma 2 in an unknown order are the values of x and y. Minus 1 whole square plus 2 square is 5. Minus 1 whole cube plus 2 cube is 7. And therefore, x power 4 plus y power 4 being a symmetric expression in x and y, which means that which one is minus 1 and which one is 2 does not matter. The value is always going to be minus 1 whole power 4 plus 2 power 4, which is 1 plus 16, 17. Option C is the answer. All right. So this was a catch problem. And this is the kind of things we are expecting to be asked. Yes, Roshan. Roshan got this. Brilliant. Perfect. Okay, here's the next one. I'll give you sufficient time to do this. Let's see if you can understand the requirement of this problem. All right, so let me start. If you are getting the answer, please let me know. So now, so you can see again the equations over here are symmetric, right? Do you see the pattern, right? The equations are just like x and y have been replaced between the two equations, right? Y plus 6 is x minus 4 whole square, whereas x plus 6 is y minus 4 whole square. So very similar equations, but x is not y. And then he's asking the value of x squared plus y squared. All right, so let's see. So obviously we'll first simplify the equations. We have to simplify this. Let's first, because we can open the whole square. So we can say y is x square minus 8x. So I'll get plus 16 over here, and 6 will come here. So 16 minus 6, I'll have 10, right? Just a simple expansion and bringing 6 over here is my first equation. And an identical equation of obviously I know that x and y have to be just swapped. So I'll say x equals y square minus 8y and plus 10 again. Perfect. So I'm looking to find the value of x square plus y square. Now again, in these kind of questions, our objective is actually not to solve for the values of x and y directly or exactly. Okay, that might be a difficult part, because if you're thinking, okay, why is this from the first equation, let's put that in the second equation. Just think about this. If I'm trying to put this expression, this quadratic expression, in the second equation, then y will be replaced as x square minus this whole thing. Whole square of that will become a fourth degree equation in x. So obviously you cannot solve for the values of x and y. The point is some kind of addition, subtraction, multiplication with the equations, and simplification of the expression helps us to reach to the objective. All right, so what I'm saying, just first of all start with adding the equation, because I know if I add, right, I'll have x square plus y square from here. Okay, so let's start over there. That's the starting point. So I'm adding the two equations 1 and 2. X plus y equals, this gives me x square plus y square minus 8x minus 8y. So write that directly by just taking it all together. Minus 8x plus y plus 10 plus 10, which is 20. All right, so my objective is this sum of squares. So just write that x squared plus y square. This thing comes over here. So this is 9 into x plus y minus 20. Perfect. This is my third equation. Well, I don't know the value of x plus y at this point of time. So I think something more is required. All right. So let's see. We have added the equations. Now let's subtract the equations. Maybe something will happen. Let's see. So I'm doing 1 minus 2. Okay. So I will have y minus x equals x square minus y square. All right. Minus 8x plus 8y, which can be written as minus 8x minus y, and 10 goes away. Perfect. All right. So take the terms on one side. So I'm getting x square minus y square. This thing is, this comes over here, 7 times of x minus y, because 8 into x minus y comes over here and plus y minus x. So 7 times. All right. So x square minus y square, that is x minus y, x plus y, x, a simple factorization we know, equals 7x minus y. Now we know for a fact that x is not equal to y. That's a good thing, because now we can cancel x minus y, the factor, on both the sides. And that exactly does the job for us. It gives us the value of x plus y is 7, which I can put over here now and get the answer. So you just had to rely on the equations, just simply manipulate. And therefore you're getting the answer. X squared plus y square is 9 into x plus y, we know now, is 7. So this is 63 minus 20, which is 43, right? 43. Perfect. Yes, Sid, that was the correct choice. B. Perfect. All right. Let's see. Next one. All right. So now let's look at few previous year questions. So this time the catch is, obviously we just have the numbers in front of us and an expression to evaluate. So how quickly we can get the answer? So, so as you know, you can see this is a that question, and obviously the objective is to get this very quickly, because the point is, if I actually start calculating 24 square, 26 square, putting it there and doing the actual calculation, remember Zad at that point of time did not have a calculator. All right. So, so therefore the point is that this expression, the way it looks like, right, some kind of algebraic, first of all, simplification can be done with it, and then the numbers should be used. So the thing is, if I just double this expression, all right, see, the point is, we know that a minus b whole square is a square minus 2ab plus b square. I'm seeing a ab thing over here. So if I can get a factor of 2 over there, then I can use the expansion of a minus b whole square. So if I just multiply and divide this expression with 2, so I can write this is minus 1 into 2 of this whole thing, which becomes minus 1 into 2a square plus 2b square plus 2c square. And now this 2ab, 2bc and 2ca, this will be helping me to write the expression of whole square. So now I can say that, okay, a minus b whole square is a square plus b square minus 2ab. So 1 of a square b square has been used. Again, I will use further b square c square now. So b minus c whole square. So, you know, both the b squares have been used by now. 2ab, 2bc has also been used. And finally, when I write a minus c whole square, now everything has been used. So this basically expansion is of this summation of squares, right? And now obviously the fact is that these numbers are, although large, but numerically close together, so the differences are small. So that's the point. Now this simplification was required, and therefore my answer is just So a minus b is minus 2 whole square 4. B minus c is also minus 2, 26 minus 28 whole square 4. A minus c is minus 4 whole square 16. So 4, 4, 16, 8 and 16, 24 by 2, 12. Right? Option D. All right. Perfect. Ready for the next one? Let's see. Okay, so this was CAT 2019. Ratio method. How ratio method? All right. So let's see this one. Let's see if you can get this one. Let me know on the chat box. All right. So let me discuss this one. I'm waiting on the comments if you're getting anything. Now, when I started, some of the initial questions we saw, we were observing the numbers and trying to figure out, right? So whenever you see equations and such complicated equations, always observe the numbers. Okay. So obviously all the numbers are like, I can say this is 5 square, right? This is 5 square. And we all know this is 13 square. So one observation that comes over here is that this is 5 square, this is 13 square, and this is 5 into 13 written over here. All right. So these expressions are very complicated, right? We have 4 variables over here. Obviously, we are not expecting to be able to solve the values of a, b, x, and y uniquely and individually. We are trying to observe the numbers and make some pattern. So the point is, the first equation, the LHS, and the second equation, the LHS, their product, right? A square, if I write this like this, a square plus b square, which is 5 square, times of x square plus y square, which is 13 square. So I can say that this is 65 square. This is 5 into 13 whole square, 65 square. And over here, 65 equals this expression, right? So I can say that this equals ax plus by whole square, right? I can make this observation very simply with the numbers. Yes or no? Now let's see what happens from here, because that is the first thing that anybody can observe. Just carefully observing the numbers should help you to reach here. Therefore, now if I simplify this, I hope to get somewhere and be able to arrive at something about this, right? Let's see. So let's say expand, right? The LHS, if I just multiply all these terms, I'm getting a square x square plus a square y square plus b square x square plus b square y square. And that equals this whole square, ax plus by whole square, which is a square x square plus b square y square plus twice of their product. So 2abxy. All right. So a square x square cancels. B square y square also cancels. And I'm left with a square y square plus b square x square. And if I take this term over here, minus 2abxy equals 0. Now look at what you have, ay minus bx. And now look at what you have got. Can you see the pattern? This is nothing but the square of this expression. This expression is nothing but a into y minus b into x, the whole square. And therefore you can say the whole square is 0. So the value is also 0. So your k, which is ay minus bx, is 0 itself, option A, right? So I hope you understand that the concept that I started with, how it is, being beautifully applied in some of the questions also, right? Observe the numbers, right? Algebra is not just about variables, but also about the numbers. That's my message. All right, let's take one more. Next one. All right, so this is a CAT 2003 question, and I put this deliberately for a fact that little bit manipulation is required in this one. Let's see if you can get this. All right. So let me know if you get this. I'm waiting. Let me start discussing now. So n is such that n is in a range, and then x is this a very complicated expression which satisfies what? So basically, you have a range of n, and then you have a expression about n, quite complicated. You have to find the range of x based on the range of n, right? All right. So you can see a lot of squares and square roots. Obviously, we see the one thing is you can always put this value of n in this expression. Just imagine calculating this. uh, Quite tedious task, right? uh, Remember when this question was asked, again no calculators were there, so that's a challenge, how to do this question without calculator. All right, so uh, we have to simplify this expression. We hope that this simplifies somehow. Now look at the denominator first. Okay, now one point which I want to bring over here is, whenever you see three terms in addition, always think, can you do the completion of squares on that? All right, you see a square root of n, you see n. If you carefully think on this, then the denominator is nothing but, the denominator is simply root n plus 2 whole square, right? This will give me n plus 4 root n plus 4, right? That's one observation. So we are expecting or hoping something will happen with the denominator, with the numerator also, right? So let's proceed to simplify that, what happens. All right, so I'm just writing it separately, the numerator over here. So just first of all expand this is n square plus, just write in, just multiply this terms, right? This is 2n root n, just let it be 2n root n plus 8 root n plus 8 root n plus 16. All right, now whenever you see four terms, always think about factorization, right? Means taking something common from here and then here. So you can see that is happening. If I can take n root n common from here. If I take n root n common, this is, if I take n root n common from n square, then what I'm left with is again root n in the bracket, and this is plus 2 remains. And wonderfully, again from here, if I take the 8 common, again I get the same expression, root n plus 2 common. So God is with me, factorization has happened, right? So this is giving me n root n plus 8 and root n plus 2. So at least when I will write this, then one root n plus 2 factor will cancel out, right? So therefore my x therefore becomes, by cancelling this term, it becomes n root n plus 8. The other factor has cancelled, and in the denominator I have 1 root n plus 2, right? The whole square, one power gets cancelled. All right, something has happened. Now further, if you look at this further, Root n can be written as the cube of root n, and 8 is 2 cube. So now are you getting one more simplification is going to happen? This is kind of x cube plus y cube upon x plus y, right? So x cube plus y cube upon x plus y will be x square minus xy plus y square because of factorization of x cube plus y cube, right? So what I'm left with is root n whole square minus 2 into 2 into root n, which is 4 root n, plus 2 square. So this is simplifying as simply n minus 4 root n plus 4. All right, so that is what we have. X is basically this. And now we can put the values of 36 and 72 and evaluate this expression. All right, so therefore at x equal to 36, let's evaluate this. We are getting, sorry, n equal to 36, I'm getting that x is 36 minus 4 into 6, 24. Sorry, my bad. I think this should be 2 root n. Just one second, small correction. This is right, x square minus xy plus y square, right? So this is 2 root n. So minus 2 into 6, 2 into root 36, 2 into 6, 12. So this is minus 12 and plus 2. So this is 36 minus 12, 24 plus 4, sorry, which is 28. So getting 28, and you can see 28 is over here. So when n is 36, x is 28. What about n is 72? Now at 72, I'm not going to get a very nice expression because it will involve square root, because square root of 72 is not a whole number. Nevertheless, we are getting basically 72 minus 2 into root 72 will be 12 root 2, right? Root 72 is 6 root 2. And so this is giving me 76 minus 12 root 2. So now let's calculate this approximately because we have to match with the options. Root 2 is approximately 1.414. Let's round it off to 1.4. So 12 into 14 will be 168. So this is 76 minus 16.8. Let's round it off to 17, right? Almost this is 76 minus 17, which is 59. So somewhere around 59 is the upper limit, 28 is the lower limit. Now remember, 28 is the exact value, right? That exactly x equals 28. Now you see over here, this is a strictly more than sign. So this cannot be my answer because I know that here we have a less than equal to sign. So the point is that this option is not correct. That option is correct, which will include the number 28 also, and the upper range, which is 59 also. So 59 is not included in options A and B because the upper limit is less than that. D is already ruled out, so C is the choice. So we are looking for an answer which is inclusive of the entire range, right? The actual range can be more than the exact range, but not less than that, right? So 28 to 59 is the actual range. So 25 to 64 includes that range. All right. Let's see next one. Let's take this as the last question for today's session. Cat 23 problem. Let's dive into this. So this is a very well seen expressions with squares and everything. So p square, q square, and 2pq, everything is there. So we expect to, can we solve for p and q from here? This is a three-way equality, right? So the first thing that we see is that this is not an equation, right? It's a equality on three expressions. Now what can we derive from there? So you have something like a equals b equals c. So what do you do when you see like this? You can get three results from here. One is put a equal to b, what do you get from there? Then put b equal to c, what do you get from there? And again put a equal to c, what you get from there. All right. You see, we are trying to go to p cube minus q cube, and we are trying to find the difference of the maximum and minimum possible value of this. So the question the language of the question clearly tells us we are not expecting to solve the unique value of P and Q. There are going to be multiple solutions, because the maximum minimum possibility only arises if you do not have a unique solution, you have multiple solutions. So let's see what happens. First, so I'm saying this is A, this is B, this is C. So A equals B gives us what? P square plus Q square, taking variables on one side and numbers on the other sides, minus 2PQ. So 29 minus 20 is 9. So I'm very wonderfully getting P minus Q whole square is 9, and therefore I'm getting P minus Q is plus or minus 3, right? Is plus or minus on 3. Then doing B equals C, I'm getting something very simple. 2PQ plus 2PQ, which is 4PQ, equals 52 and 20, 72. So I'm just directly getting P into Q is 18. Wonderful. So this is my first result. P minus Q is plus minus 3. Second result, P into Q is 18. Third result, A equals C. And I'm getting P square plus Q square plus 2PQ. This comes over here. This comes over there. 52 plus 29 is 81. Right? This is my third result. In fact, I'll obviously say from here P plus Q is plus minus of 9. Wonderful. Right? P plus Q whole square was 81. P plus Q is plus minus 9. Now I need to go to P cube minus Q cube. All right. P cube minus Q cube. So we all know that is P minus Q times of P square plus PQ plus Q square. Now I have not solved for the values of P square plus Q square directly, right? But I can, because from here P into Q is 18. So if I put that over here in this equation, I can get the value of P into Q also. Or in other words, if you look at this very carefully, subtracting the third equation and the second equation in its initial form over here, right, will give us the value of this expression. So P minus Q from there can be substituted as plus minus 3. And this, we can observe this expression is this expression minus this expression, right? So this gives me 81 minus 18, which is 63. This is plus minus of 3 times 63. So PQ minus QQ has therefore two values of the same magnitude, one with the positive sign, one with the negative sign. So can I say that that maximum value which I'm looking for is nothing but plus value of 3 into 63. 3 into 63 is 189. And the minimum value is that with the negative sign, which is negative 189. So the difference is nothing but 189 plus 189, which is 378. Right? So this brings us to the conclusion of our first session of algebra, where we have seen how algebraic manipulations and simplifications and observation of numbers, all of these skills are required and tested, right? All right. So I hope you found this session useful, and we'll see you quite soon in the next one. I'm looking for all your response on the comment section. Uh, if you watch the video, let me know how you think about that. And yes, one important announcement is about the CDC mock, the countdown to cat mock, which has just opened uh, today. It has opened on 24th May and open till 2nd of June. So uh, just something that, I hope all of us who are preparing will find useful, right? All right. So thank you. Thank you. And see you in the next session. All the best.